Hello and welcome back to the course on computer vision. Today we're going to talk about some applications of GANs. Alright, so let's have a look. GANs can be used for many different things. And for instance, here's a couple. Generating images, image modification, super resolution, assisting artists, photorealistic images, speech generation, and face aging. So those are just a couple of examples of how GANs can be used, and we're going to look into a few of them in more detail. So not all of them, but just a few. So just to kind of like give you some ideas maybe for how you can use GANs in your own life, in your work, maybe in your own projects, maybe in some applications that you might want to create. Alright, so generating images. What can GANs be used for in this space? Well, we already saw how GANs generate images. That's kind of like the core use case for GANs, or how they came to be. And we saw that an example of dogs. Let's have a look at a more successful example. Like you could see that it's really hard for a generative adversarial network to generate an image of a realistic dog. But let's see where they do actually really well. So for instance, these are, can you just by looking at this, can you say what this is? What do you think these are images of? They're all images of one certain thing. So you probably can already tell what they are. And by the way, this is just like after one iteration, after one epoch. And this is taken from an official paper, which I will link to at the end of this tutorial. But this is just like a very undertrained GAN, but you can already kind of see what it is. If you can't yet tell, then I'm going to show you just now what it looks like, what these same images look like after more steps. I think it was like after 12 steps. So let's have, not steps, after 12 epochs, after 12 training cycles. So if I'm going to show you that, and let's see if you'll see if it's easier to tell what's going on. So there you go. So these are actually generated images. And as you can probably tell, these are images of bedrooms. And this is an example of where GANs are doing really well. Some of these bedrooms look so realistic, right? So here you got a bed, you got a pillow, you've got a window. Let's see what else. Here you've got like a big window here somewhere, and somewhere there's a bed here. Here you've got a bed with some pillows, another window. You can see the lighting changes, the colors are changing. Here you've got a bed and kind of like a closet over there. You got a bed up close over here. So you can see it's doing well, and that's one of the cases where GANs do well. Not just bedrooms, but not just images of bedrooms, but actually when you have a very confined domain where something is like very, like bedrooms, unlike dogs, are usually much more similar one to another, even though there can be a lot of variety, but there's less variety than in images of dogs, because dogs are so different and backgrounds are different, their positions are different. But for instance, for bedrooms, it works quite well. So I'm going to just go back and forward a couple times so you can see. Just pick an image and try to observe how it changes. For instance, look at this one. You can see that it's quite pronounced here. Before, it was not as well defined. Let's have a look at another one. This one looks quite good. Did look like that. It would look a little bit different as well. So as you can see, the more training you put in, the better the final outputs. Like these ones, they don't look as defined over here, but once you do more training, they look more defined. So there we go. If you want to generate some fake images of bedrooms, then GANs are your go-to. But also not just bedrooms, any kind of like confined space or confined type of image or object that where the variety isn't that great, and then GANs can do a pretty good job. Image modification. Okay, so what does that mean? Well, let's have a look at this example. So here we've got, again, it's from the same paper, and here we've got a smiling woman on the left. These are images generated by GAN, all of them. Then you got a neutral woman in the middle, and then you got a neutral man. So if you take the smiling woman, so basically what they're showing here is that through GANs, through the way that these images are generated, they're actually assigned a vector. If you look at the neural network that represents them and represent that in a vector, you can then do arithmetics with those vectors. So you can take a vector for a smiling woman, subtract a vector for a neutral woman, and you will get, and then you add a vector for a neutral man, well, you will get the smiling man. So basically, by subtracting this from this, you'll get a vector for the smile. You add it on top of the neutral man, and you get the man that is smiling. Very, very interesting. A little bit creepy as well, but that's the state they're at now. Here's another example. Man with glasses, subtract man without glasses. Completely different man, as you can see. And then you add a woman without glasses, and you get a woman with glasses. Very interesting. And so similar results have been already seen in the space of text, where, for instance, a very famous example is if you take if you use neural networks to represent words or like sentences, and then you take if you just take if you take words and represent them with vectors, and then for instance you take king and you subtract man and you add the word woman, then you get something close to a queen. And that can be that has been achieved before, but it's not as it's not as big as a breakthrough as the same with images, because images actually represent not just something that we have like an alphabet or different words. They actually represent something that we can see in real life. And as you can see, this woman with glasses over here is pretty distinct. It's pretty, you can really see that it's a woman with glasses, even though these people never existed. This is just all GAN generated images. And for example, here they're showing that if you try to do the same with just arithmetic operations for pixels, then you will never actually have a result as good, because as you can see, you just get like overlay of different images, and that's nowhere near to as good as what we had over here. All right, so that's what is this? What was this application? Image modification. So this next one is super resolution. Here's an example from Ian Goodfellow's presentation where they had an original image which looked like that. Then they reduced the resolution, so made it more grainy and less detailed. And then they applied different algorithms to increase the resolution back. And so there's bicubic, there's SRS net, and then there's super resolution by GAN. And so you can see that the GAN did a really good job, even though this one's a bit smoother. GAN did a really good job, and you can see that it's quite crystal crisp. Unfortunately, it'd be really cool if they had the image of the low resolution image that they created in between here. So the image that they took from this, what they created, and then the results. That would be cool to compare. But I couldn't find that image, unfortunately. So all we have to compare is to the original. But already we can see kind of like how this performed. Like it performed overall well, but if you look in detail, like for instance here on the hat, there's a pattern and it's not here. There's some like horses or elephants there, they're not here. There's certain detail over here that has been destroyed, but nevertheless this is already better than you could see previously. So now imagine if you didn't have the original, if you just have a low resolution image and you want to recreate the high resolution version of that image, then you could use a GAN for that as well. Okay, photorealistic images. This is a very interesting one. So there was this it was this application online, Pix2Pix, which allowed you to, like, you draw something with just online, and then you apply a generative adversarial network. It just presses button basically, and you get a photorealistic image. So the GAN uses this as an input and learns what a human should look like. It already knows kind of from its training what a human should look like, and it will overlay styles on top of that. It will overlay, basically it will turn this image into something that looks like a real photo. And this service was so popular, they got over like 2 million views, 2 million visitors on the website. The people that put it up, they just didn't have enough funds to maintain the server, so they had to close it, unfortunately. But there's a really cool YouTube video of an artist playing around with this, and I will link to it at the end in additional reading or viewing in this case, and you'll be able to check it out. There's some very interesting stuff, but like this is already crazy, like from just a pencil drawing, line drawing, you get a realistic looking photo like that. Face aging, so a popular one. So I think these are all Hollywood actors. I'm not actually sure. They look like Hollywood actors. So I don't really know the background of this, how they did it. Did they look, maybe they took these photos over here at the start and then they aged them. But basically, what was applied here is a generative adversarial network to generate a sequence of photos from a photo. So basically you can start with like a young photo and see how a person will age over time, by applying generative adversarial networks. Of course, they have to go through certain training to understand, the concepts of aging for those concepts to be programmed into or embedded into the neural network. But this is another application of general adversarial networks. As you can see, quite a lot of different applications. So the couple of resources that I mentioned, this one is a paper called Unsupervised Representation Learning with Deep Convolutional Generative Adversarial Networks, so DC GANs. This is like a step above GANs, or an enhancement on top of GANs, where the networks are even deeper. And you can find it on archive there. And it's actually got a lot of those examples that we talked about. They are given in this paper if you want to read about it and see some additional images. And the YouTube video that I referenced is called Artists versus Pics to Pics. Is this humor or horror? Check it out. There's just this artist drawing these images. If you just Google artists versus pics to pics, you'll find it. This artist drawing these images and then applying the GAN to see how it'll overlay human skin and hair and tones over, and it's very interesting. A lot of the time it's very creepy. Alright, so that's application of GANs. Hope you enjoyed this tutorial, and I look forward to seeing you next time. Until then, enjoy computer vision.